So it's
Anywhere
recording.
you want. Just remember what your number is. 41. Where's your lid? Oh, right here.
Yeah, make sure it's live on. Oh yeah, yours gonna be different.
Yeah,
Rebecca.
you're not like
And
everybody.
Selena, you guys should be
Tighten it.
different.
Yeah. Tighten it. Where do you want? Anywhere you want. You're 42.
So write that down, okay? The numbers.
43. 44. 45.
All right.
Okay?
There we go. All right. So there's the mounting done here with the mass spec. And then what we're gonna do is we're gonna head back to the actual computer room where that's where we're gonna be actually running it. Oh, go ahead.
Okay, the first thing I want to show you guys is what standard looks like for today. So you guys have already done HPLC, correct? Yes. So you all know what an HPLC graph looks like. Yes. Caffeine elutes out at 4 point something. 4.7. This one is at 4.6, but generally it's 4 point something. Beautiful HPLC graph. This is a very typical MS graph. Looks like horridness. You would think that or that would be caffeine. But you have to go based off of what your HPLC graph told you. So your HPLC graph told you that it eluted out at 4.6. Now you need to give 0.1 to 0.5 seconds for the MS to pick up what the HPLC was saying. So instead of going over here to 3, you need to go past 4.6 in order to read your caffeine. So whatever your elution time is, you need to go past that to find where your peak of actual sample is.
I have a question.
Yes.
So you're saying that so once you look at the elute time from the HPLC, you have to, it's a different eluting time in the MS at the time.
Slightly different because it's going to. So.
Yeah, but that shouldn't.
Okay, so what's going on is you have a sample, it ejects in, it goes through a column which gathers everything up based on its polarity, and then it reads it through the UV detector. Then it sends that massive sample to the MS. It has to go through a whole bunch of coils, a whole bunch of tiny little capillary tubes, be evaporated before it can finally hit the detection.
So you're saying that the time that it takes for it to go through all that, you add that time basically to the MS time.
Right.
But doesn't
Should we just start from the beginning?
Exactly. When it actually, that whole time that it's going through that, it's not taken into consideration. It's actually, because once it enters the mass spec, that's a beautiful, it should have the same.
Well, it's only off by like 0.1.
Yeah, so it's not that long of a difference.
It's not like it's a minute off.
Yeah.
It's only off by like 10 seconds.
But it's contact closure, Caesar. That's the reason why. Because they're not the same instrument. They're not the same company. Two different separate pieces of equipment. That's why.
If you look at this, based on here, this is right here, 4.6. See how it's just starting to take off? So it's about a second behind before you see your actual caffeine. 0.1. So it's not instantaneous. It's not like 4 and 4. It's 4 and 4.1. It's just how the machines have always.
Yeah, it has been set up. That's why it's contact closure, Caesar. That's the reason why. It's two separate. The instruments for one company, the mass spec was bought from a different company than the HPLC. So there's a 10-second gap in between the two to contact. Yeah, that's right. Yeah, if they were on the same thing, then it would be instantaneous like the way you're saying. That's what happens.
Okay. Another thing, when you open up these graphs, because you go over here to open or whatever, it opens it so that you can't do anything about it. You can't move it around. You have to click this little pin right here in order to search.
Push pin. It's like to kind of put it on there.
Search for your sample. Okay. Okay. So now we're going to actually do the setup for what you guys are going to be doing today. So the first thing you do is you're going to go over to Excalibur, which is this program right here, which is this X down here, the bottom. Okay. And I've already loaded the sequence setup for you, but you're going to click sequence setup, and it's going to be loaded here. The only things you're gonna change is instead of Mountain Dew Dr. Pepper test, you're gonna put your name. So you're gonna double click into the bar, or I'm sorry, single click into here and change the name. Okay, you're not gonna do anything to the other one. Then when you're ready to run, you're gonna highlight it so that it's blue, and then hit this little test tube with an arrow running through it to hit the run sample. It's gonna pop up a box, and you're gonna say okay. Then this is gonna start going through contact closure and trying to get ready. While that's waiting, you're gonna highlight the second row, hit the test tube again, hit okay again, hit the test tube twice, hit okay twice. So you're gonna do the clean 2 times. So you're gonna highlight, hit, okay. It's gonna look, highlight, hit, okay. Then you'll have 3 things running, waiting to run. Does that make sense?
That's what we call the queue. This is waiting.
So I'm actually gonna walk you through it, and they're gonna watch you do all the name changing and stuff. Then you go over to the HPLC, and this one's already running, it's already going. The only thing you're gonna do different than I think you guys did last semester is you're gonna go into easy sequence, load the caffeine D sequence, and I'm gonna change it for you right here so that it says 3. And it's gonna load them here. From here, you're gonna change the name of everything. So this is gonna be clean because you don't care about it, and this one's also gonna be a clean. So you're gonna put your name in here. You're gonna put what your vial number was here, so it picks up your vial.
That's very important, the number.
If you don't do that, then it's gonna pick up
Number
methanol, and you're not gonna get
Yeah, which is
it.
number
For
1.
one sample, right?
So it's
Just
just
cleaning
doing,
it twice, just like a
Right.
longer period of time.
right. So the clean runs right now are at 15 minutes. And so it's gonna clean 15 minutes, then start over cleaning another 15 minutes. Okay? Then once you change the name here, you're gonna hit save and add queue, and it's going to start. You have to do Excalibur first. Excalibur is the one that waits for contact closure, which is just the little signal that the HPLC sends the MS that says, hey, I'm sending you a sample, wake up. If you do it the other way around, the Excalibur won't start acquiring data until the second run on the HPLC, which will be your clean, which will do you no good. Questions? Okay, so now I'm gonna walk you through, so you can set it up.
Can you set all the keys up at once? Or no?
That's what we're about to do.
Yep.
Just once, and then take type. No.
But you have the option.
Click on the side. No,
You
it's
already clicked on it.
Okay. Okay, now you can run it. Okay. Okay. Now do the clean. So click on it.
Yeah, the clean.
Click on the wrong sample, hit okay. Now do the same thing for the clean. Do it twice. Nope.
Next thing, right?
Good. Now go to your HPLC.
And you see how you did those 3 things? The 3 things showed up on the left-hand side, those drop down.
Easy sequence. Load your or it's already loaded for you. Change the name. I need to understand. What's your file? Number? Now save that. Now the cool thing is you can actually watch it. So if you go to instrument controller, it's going to show you that it's going to start. And now you've started. Now the next person can come in. So who was 42? Or who was next? It actually doesn't have to go in order.
Doesn't matter.
You want to go next?
I have to wait.
Well, Selena, you have one of those caps, right?
Yeah.
You have caps.
Okay,
So
caps
Selena
are gonna go
and
last.
and Rebecca. Okay. So we'll have only because theirs may evaporate off. That's why we're using those caps to see if it works fine. We need to penetrate through and pop it
All
out.
right, now go to Excalibur. Yes. Change the name. Nope, you have to highlight the clean. Now. And one more time.
You see how it adds it every time? So every time there'll be a total of 3, and there's 5 of you guys, so in total it should be 15.
Okay, now go to the HPLC. Now go to easy sequence. Hit load sequence. Open caffeine B. Open. Change your name. Now hit what your file number is. And save that key. Done.
All right.
And you're done.
All right. All right, Caesar, you're up.
What's the thing? Why is this deleted? Isn't it supposed to be clean?
I'm deleting them at the end.
Oh, okay. I see. We do that twice, right?
Yes.
So the sequences is what already Cassandra had made for you guys. That has all the parameters, everything ready to go. The method.
The
which
sequence is what
It
they're
was
making.
cleaned beforehand, so then my sample runs and then cleaned after twice.
Right. Yep, save that. You're done.
I thought I was slow.
Now, either one of you.
Sure that I do.
All right. And so the idea by doing it, like I said, there's lots of different ways of doing this, but the idea is like to have you guys just load up all your samples as a class and just come back when it's ready. Or if you want, so you can actually come in, load up the method, do the sequencing yourself, then scan your samples, and then just collect the data, and then log off. Done. And then the next person who, whenever they want to come on, will do exactly the same thing. They will load up their method, the sequence, which we'll tell them where we'll be at. They do the sequencing, and then they will just take their sample. Here, we're just doing it all in one swoop.
Yeah.
So when you guys are ready to come back in, whatever time it is, like for Rebecca, you come back tomorrow or on Tuesday, whatever, to pick up the data. You're done.
Okay.
No, you don't have to wait.
So we have to wait
no,
until
you're done. You don't have to.
to go home.
Yeah, technically you could. That's the idea. And then you can log on. If here on this computer, you log on, and then boom, there's your data.
So in
That's
order
cool.
to get your graphs, can we set up emails to us?
So to get your HPLC graphs, you can save them to either the desktop or your flash drive as a PDF. I can show you how to do that if you're here long enough. For the Excalibur, the only one I know of how to do MS is print screen. And then you can take
Snapshot of it. Yeah.
Excalibur is specifically for math.
Yeah. Yeah. And whereas Camp Station is for HPS. Yes, you can. Yeah. So it's a pick. Yeah. No, like I said, don't even worry about that. Like that's the point. That's the advantage here is like it'll be here for you, ready. So you want to come back on Friday tomorrow, you can, because we'll be here. You can get it.
I want to start working on Turn on Tuesdays.
Okay, all right. So that'd be cool. Yeah, but that's the advantage there. It'll be there for you, and the best way actually is to have done this thing put it on the cloud. So basically, you guys can just log in from home to here, and then boom, just get it without even have to worry about USB or anything like that. That's another part we're trying to cut out. However, and this is something that we run into a problem is because there's a firewall issue. So you have to get permission first of all from here to get you in, to get approval, to let you in through the firewall, and then finally get able to remote access the computer here. So that's the only thing. We're working on that. That's the only part. So right now, this is the best we could do here because why? We're still at Dominguez Hills.
So
But
with
we-
the cloud, I'm sorry,
Yeah.
with the cloud technology, does the system has to be running for you to access it from home?
No, well, the server will always be up and running. It's never going to shut down.
Okay.
So the idea is your data you collected will be available 24-hour day, 7 out of the week. As long as the server doesn't shut down, it's on that cloud. The machine, though, it's the same idea, is to have it on all the time. It never shuts off. So the idea is you could take data, even say at midnight or 1 a.m. in the morning, and just run it. You're done, and then there's your data. You're ready to go. That's the advantage of having done this thing as well. Okay, so but we're not there yet with that.
Save the file. So let's just say that this was your file. Let's just say it was. It's not, but let's say it was. The way that you would save it is you'd go here to print, and then have it print into Adobe PDF. And you can print it to the desktop or whatever, and then this computer that you're logging into has internet, so you can then sign in and email it to yourself. That's for HPLC. Now, go ahead.
No, I was just gonna say, so by when would the data be available for sure?
Well, what number are you?
You were number 3, Caesar. You were the third one.
So 45 times 3.
So what's that?
45
135 minutes, which is 2 hours and 15
something.
minutes.
Yeah, and then you can come in and take your data.
Pick it up.
So
And like I said, guys, you don't have to do it today. It's gonna be done.
here.
It'll be here. So like Rebecca, you'll be the last one technically,
I mean, you guys-
but you don't have to wait here until like almost like what 5 or 6 p.m. to get it.
Yeah.
It'll be done. You come in tomorrow and pick it up.
Okay.
Done.
It will still be here by Thursday, right?
It's
We're gonna
gonna
be
be
here
here.
Thursday doing the experiment anyway.
It's going to be here until I leave the school,
Okay.
which will be this time next year. So, worst case scenario.
The software and everything, nothing is deleted or anything like that. So
Yeah, it's saved.
Yeah, and on this thing, going to the server, basically, since that thing has a huge amount of space, nothing gets deleted, and it gets backed up. It is meant right now in case if something was to happen where, say, there was a power outage, or the hard drive just crashed, something like that. It's been backed up. Edgar set that up first, so that way it's supposed to repeat. It's supposed to back itself up almost every day. So 24 hours, it backs up. Next day, it backs it up. So you're never ever gonna lose this stuff. The data will always be there.
So in order to get the data from the HPLC, you have to go under the data analysis tab. That's how I went to find the print or whatever. And then in here, you need to find yours, which it's, how do I explain? In the column, it's not named after your name. It's named after the method that you used. So you need
caffeine.
to find the method that you used.
Caffeine.
So I'll show you. So over here, this is what it's going to look like when you go to the data analysis tab. You need to open this up and then go down to caffeine D to today, which right now it's running still, so it's not going to show. But you're going to go to the one that says 422, and when you open it, then you can see, oh, that's my name, and that one's yours, and that's the one you print. This is the standard.
Oh, okay.
Okay?
And that's all we need to print that.
For HPLC. For Excalibur, you're going to go to this first tab that kind of looks like a Venn diagram that you had to do in elementary school. With a whole bunch of boxes and arrows. When you click on it, you get this. You're going to go to the qual browser and open up yours. And it's going to be based on your name in this one.
This is for the mass spec, right?
This is
For the mass spec now. That's right.
So for mass spec,
Oops.
ours is I don't know why that one got me. That's weird. I wanted to save this. You could,
So you click on your name and then that's.
yeah, and then it pops up. Yeah, I don't know. The printing on this one doesn't print PDF, so the best thing you can do is take a print screen of it, a snapshot of it, and then edit it in Paint, which also is on this computer, and then save it as an image, like a JPEG image. That's the only way I know to save these graphs, offside of this computer. Okay?
Oh, you can.
You can. It's just slow. You guys can try it this way and tell me if it works.
Yeah, yeah.
I've never done it, so.
You can save that one right now. We just put it on the desktop,
Yeah, try
on that
it.
computer. Yeah, you can just save it on there. Then you go on the desktop, it should be on there.
Dr. Rodriguez, do you guys have Chemtron?
ChemDraw, no, but I know you're no. We haven't like had a need. Well, let me stop. Let's see, just to end it then. All right. So that's it. So right now, all we're doing is just waiting, right? That's it.
Yep.
We just wait.
So
Is
that's
that-
your first graph.
That's your first graph, all right?
I'll take your graph.
That's, looks really nice.
And that's common. That's the expected look.
Oh, okay.
So these two peaks here are something else that the methylene chloride extracted out from the soda itself, which is expected. There's a lot of sugars and crap in soda. But this 4.7 is your caffeine. So now
Why is it so?
broad because it's above 20 parts per million in the machine.
Yeah, that's
and
the
the
problem.
higher concentration you have, the broader.
The broader the peak. That's the reason why. We found that out the hard way. So we knew
The
that.
first time we did it,
Yeah.
it was like this.
It was pretty bad.
Oh,
Yeah, that's the reason why we thought it was broken. It wasn't. We had completely
That's why it's so
contaminated it.
But
So
I
now-
believe the Mountain Dew was fairly thin.
So that's it. So and I said the best thing also is we're not in that room, so it was all done, you know, kind of like cyber enable a little bit. At least we're not in the same room, you know, in a small little room. We're just running it from here for right now, and you guys are getting the same experience if you guys were actually in that room in front of the machine, but there's no need for that.
No, that's the standard. Oh, it's still in box. Yours isn't done because the clean is still going?
Can you see it live, Cassandra? The thing, you know,
Not
on the
from
mass spec.
HPLC. But the clean is, he doesn't want to, she wants to copy that.
Okay, no, that's cool.
So,
But is there a way to see the mass spec running live from here though? Right? Okay. So when I was doing the clean, oh man,
That's